Hello, I'm Sean, and this is...
I'm Estyn.
And we're going to talk to you about developer productivity and...
We can see you.
Okay. And Typescript. And we're also going to be presenting it. So I'm going to start off with a little demo. Like, quite sure a lot of you have used JavaScript before, and you're like, hey, I want to use TypeScript. Is this going to be really, really difficult? And I'm hoping to convince you that it won't be really, really difficult. So I'm going to show you like the most generic JavaScript thing you'll probably ever have seen. I have an animal class and a snake class that extends animal, and then a goat, because goats are cool. And they each kind of override move in a slightly different way. And now I can let Sam equal a new snake, and Gary equal a new goat, and I can call move. And if I run this, you'll see exactly what you'd expect. Now I'm going to go and add a little bit to my code here. I'm going to let Adam equal new animal, and then Adam dot move. Cool. Everything's funky-dory. I'm going to run this now. And this is one area. I just want to kind of throw this out as an example. Like, this is a really simple case, but you can see here at the very bottom is animal moved undefined meters. This is now a bug report coming in from your users that you, if you were a little more careful, could have easily caught. But it was a pretty forgivable mistake. Like, all these functions look basically the same. So what I'm going to do now is just move demo.js to if I can type, TypeScript. Go back to my editor, open this up, and you're immediately going to see I'm in code here. Code is complaining that I have used move incorrectly. If I'm not using an editor with nice language inflection, it's not dreadfully important, because if I try and run this now, it is now a compile time error, and my problem is a developer and I don't have a bug report rolling in. Thanks. Can you read this? Okay, cool. So now I'm going to fix this by going, he's going to move 5 meters. That's also pretty cool. I'm going to run this. It's going to run just fine. However, it's a little bit, what have I done? What have I done? Did I forget to? I forgot to save. He now moves 5 meters. I'm going to come back here. I'm just going to show off a couple of other little things. Like, I can expect meters to be a number. And now you see it's complaining again. So this is just a really quick demo. Like, adding a little bit of structure to your code can actually like increase my productivity as a developer, because I'm not spending my time fixing silly little mistakes. And the errors I get back are pretty, it's like, oh, I'm at this line, and this is what's wrong. So it kind of just speeds me up a little bit. Coming back to our presentation here, though. A few little hints when you're getting started in TypeScript. There's a repo called definitely typed, which is, if you npm install at types library, you'll probably just get types for it. So like 2 that I find handy are core.js and Node. It just gives you some foundational types to use right away. And you're already seeing more and more libraries, including typing files in them by default. Like, I think you were saying, does underscore do that, or jQuery? That way you don't even need to go and grab an external one. Like, the language is actually taking off at some level of popularity, which is really awesome. And as far as ES6 features, you can use almost all the new shinies, not quite as high as Babel, which will grab something as soon as somebody starts talking about it in a cafe in San Francisco. But as soon as those people write a proposal and it gets up to stage 3, TypeScript will be like, we'll do that. So that's kind of a really beginning intro here. And now I'm going to pass this off to Estyn to show how he uses TypeScript on a day-to-day, because he's been using it for much longer.
Sorry. Take a second here to hopefully just work. All right, so how I use TypeScript. So Sean and I were talking about this. We've been using TypeScript at PunchCard for probably about 2 years now, but we've taken a very sort of incremental approach. So instead of focusing on like some of the stuff Sean just showed about where you can do classes, inherits and stuff like that, that stuff is sort of TypeScript brought that in, and then ES6 sort of brings some of that in. We've been primarily using it, focusing around sort of developer productivity and code quality. So the things we're looking for is making sure that we can write code quickly and have it as high quality. So the tools that we're using around that is sort of the IntelliSense and the Code Lens. So those features are available in VS Code and Visual Studio, but also in any other editor that can use the TypeScript language features. The other big thing that we're using is typings. So typings, like Sean was mentioning, are also included in a lot of the libraries, but also when you develop your own libraries to be consumed by your own developers, you can include your own typings. And in fact, if you're writing your code in TypeScript, it provides typings for everything that it does automatically. And if you're writing it in JavaScript, you can always write a typings file that it can then consume, and then you're making sure your code works that way. For ES6, we use it a little bit. Like we used, like when we were doing our AJAX calls, originally we did everything through promises, and then we moved everything to observables, and now we're moving everything to async await. And so it's like redo it every time, but every time we drop about 20% of our code. So if you look at our code now versus what it was before, we're probably dropped about 50% of our networking code. And that just means there's less opportunities for errors. It's easier to understand the code by looking at it. If you then transpile that to something like ES5, you're then again going to get a lot of JavaScript, but at least that JavaScript has been tested by a lot of people as opposed to custom code that you've written. And then the biggest thing that we do is refactoring. So in our company, we take over projects from clients of ours. We're consultants. We're brought in whenever we're working on sort of large projects that are trying to get modernized. So we'll often come in and we'll take everything from JavaScript, we'll move it into TypeScript, and then we can start doing refactoring with confidence. If you don't have TypeScript or really good unit tests, and I've never gone into a client that's had really good unit tests, then you don't have a lot of confidence when you're making those changes. So you'll make a change and then you're concerned that I just renamed surname to name or to first name or to last name, but I only want that to be on certain objects, whereas that name is pretty generic. It may be used on a lot of different objects. So you can't even do a find and replace. You really need to go through and every single instance test it, write a unit test for that. So it is quite time consuming. So we'll give a quick little demo of a few of those things here. So right here, a blank project. You can see it's pretty simple. It's index.js. If we look at the packet.json, the only thing I brought in here is just Lodash. And what I want to show here is just some of the features that you get from having. Can you guys type something to make sure it's actually big enough? So I'm just going to require in Lodash here. And then if I start using it and I start typing, I already get IntelliSense or code completion, depending on what wording you want to use here. But even though I'm in a JavaScript file, I'm getting that because Visual Studio Code is using the TypeScript language service. The TypeScript language service is saying, okay, you're bringing in Lodash. I'll check your node modules where Lodash is there typings? If there is, it automatically loads it. In this case, there's not. But then it says, okay, I'll check the definitely type that Sean was talking about. Is there a definition there? Yes. So I'm bringing that in automatically. When you're using a product like Visual Studio Code, Visual Atom, and a few other ones, they'll automatically do that look for you. So you don't even need to do that. You just get that sort of automatically by telling your editor to use the TypeScript language service. If it's not found there, then you can actually explicitly tell your editor where the code is. This is really good if you're doing a sort of Webpack or something like that. Then you'll need to let Webpack know where that is because it's not quite as built in. But that's just telling it to basically do npm install @types and the name of the library that you want the typings for. And some of the nice things here, so if I was doing like a sort or something like that, I can easily see all the features that are available here. It's fairly time consuming to go to the documentation, look everything up, go back and forth, especially if you're using it a lot and you kind of know what you want, so you know you're sorting, but I don't know if it takes in an array or if it takes in a list or I have to pass in a function. So it gives you exactly what this can take, what it will return, and even better, if you do it wrong, it'll give you like the old red squiggly underneath it that makes it a lot clearer. So we'll do another quick example here. So here's a React example. I do most of my development in Angular, but we do a fair bit of React as well. So I'm by no means an expert in React, but this is just to show that, so if you see this one, it's a TSX file instead of a JSX, instead of a JS. So you can see that normally in React, when you pass in your prop types and your state, they're just object literals, or simple objects. And then you have to write a prop check, to make sure that they're passing in the proper thing. That runs runtime, so if you're passing the wrong thing, your prop check, either your function will just fail because you passed in the wrong thing, or if you've done a nice check, it'll say it failed because of this. So you get a little bit more information. Here what we can do is we can do compile time checks. So if we look at our to-do item props here, we're defining an interface, just saying that it takes a to-do object and sort of what the functions are. And with that, we can be confident that when we build this, the objects getting passed in will always be correct. It doesn't save a lot of typing, as in the interface here that I'm writing is probably about the same amount of writing I would do with prop types, but what it does do is move it from runtime to compile time, and it does make it, I think, a little bit better in that you have this to-do object, so you can reuse that object. If you're doing that in regular JavaScript, you could try using something like flow, but flow is not going to catch that particular error in runtime. It'll catch that, or sorry, it won't catch it compile time. So depending on what kind of setup you have, you'll have to write unit tests around that. No matter what we do here, you're still going to need to write unit tests. This doesn't eliminate any need for all of them because you write bad code, you're going to get bad results no matter how you do it, right? It's not going to stop that, but it does eliminate a category of errors. It also gives you sort of tooling support. So if I'm working on this right now and I'm like, well, what's in a to-do? You can click on it. It gives you an inline view of what your to-do is. You can edit it here. Or if it's a larger piece of code, we could just, I'm trying to remember not to do this with keyboard shortcuts so you can see it. We can go to the actual definition, and then I can make a change here. If I just make a change here, it'll just change here, but then other places might be broken because I've changed something here. But because this is all strongly typed throughout the whole process, I can rename this, and I could change this to, I don't know, IC or ID or whatever it is. And what it does is it checks all my code, sees where this is used, see where this is imported, it goes through my entire code base. Right now it's opening that for me and saying, okay, well, you need to rename it here. We've renamed it for you here. So it's renaming all the places that it exists so that I can make this rename with confidence, and even if something else is ID somewhere, I know it didn't rename that ID because it understands the context that it's in. Another nice thing is if I don't know if I'm actually even using this object, which with JavaScript code and old legacy code bases is pretty common. You'll have a bunch of code and you're like, I don't know if there's ever recode called, so hopefully for the best, right? So what we can do here is go to, you can see where you're implementing it, so every time that it's instantiated, and you can also look at the object and see every time that it's actually even defined. So it gives you a lot of flexibility to refactor your code, from my perspective, in a lot easier way than it would be if it's just JavaScript. And for a lot of the time, we will just even rename files from TS or from JS to TS and just use this refactoring as a starting point for when you're refactoring the rest of your code. So you don't have to do all the complex features and functionality that TypeScript gives you, because TypeScript is huge, but you could just take the pieces that make sense for what you're working on. And I'll let Sean show the next piece.
Cool. So a little bit around what Estyn was just talking about, I want to show you something we're working on at Java right now, and where we're writing this in TypeScript, and where if we want to go further down the TypeScript rabbit hole, how we could even get some more benefits. So the service at a high level is a notification service. We have multiple inputs, Rabbit, webhooks, whatever else. And then this big blue bar here is basically an observable queue throughout the thing. And then we have different objects that will latch onto this queue and handle events as they come through. So since we have multiple inputs, it's really important that they're of a predictable shape. And this is the interface that Estyn was talking about. This basically defines, hey, I'm a generic JavaScript object, but I should adhere to a certain shape, and I can even define that certain properties on this should only be read-only. So if I ever go and try and write to an identifier that doesn't make any sense, just slap me down. So now if I want to go and use this, you can see here I am defining something. It just looks like a regular object definition, and then I'm telling this function that it takes a stream event, and it just ensures that the object that I'm passing this function, the shape matches what this function is expecting. Further on from this, we can do like some abstract class stuff. So just like shape checking on maybe my data structures, I can do shape checking on my classes. So I can be like, hey, I want an event handler, a generic class that needs to define whether or not an event is relevant for this handler and then how to handle this event. So I have this abstract class here that has is event relevant, returns a Boolean, and has handle event, which takes an event. And it's not instantiated directly, but it can be used by another class to enforce that this handshake that I've created is actually valid on both sides. You can kind of think of them, it's like an API agreement within your internal code. Just like I expect, I don't know, Twitter to have a certain consistency to their API, I'm now defining my code files are going to have a certain consistency in the way they interact with themselves. Also, you can see in the code here that I'm not bothering to check that event.type is even defined because my interface has defined that this is a guaranteed read-only property of this object. A bit further than that, we have Innumerable Types, which I'm quite sure if you're familiar with JavaScript, you've done a lot of like, is this match string, which is, you know, really easily typable if I put an extra I in there or a lowercase l or something, and then everything breaks and I don't really know why, and it wasn't obvious. So an enumerable can actually define an event type, and it'll be either visit or task. So my comparison moves from that string comparison to is this event type stream event.visit. So I'm programmatically linking these two things in a way that doesn't involve string comparison, which is really, really nice. So that's kind of just a really high level of what we could use here, and just to kind of just solidify some things. And yeah, so there's also some, I think, common concerns about TypeScript. I think one of the first ones, if you've ever tried it anywhere that's not, probably recently, you've probably ran into type definition problems. I think personally they've gotten a lot better, and 6 months or so I've been using it, I've had to track down my own type definitions, I think once. And I know, Estyn, you've been using it a lot longer. And
yeah, it's been getting a lot better.
Yeah.
I know what we do now is like for internal stuff too, like when we build our APIs, they can actually spit out type definitions as well. So all of our APIs we write in C#, they're strongly typed. So the object that we're passing back passes back the object, but it also passes back its type definition at the same time. So then that when we develop all of our code, you're sure that everything matches up throughout the whole process.
And another concern is, am I locked in? Is this going to be another CoffeeScript? And 3 years from now, I'm just going to hate my life because I have all this code that is useless. And there is some concern here, but I would say TypeScript is syntactic sugar on top of JavaScript. As a goal, it almost wants to just deprecate itself as a project. It's just like we want JavaScript to have these features, so we're going to do them in the most JavaScript compatible way. All valid JavaScript is valid TypeScript, which you can't say about CoffeeScript. So I would say there's significantly less risk about TypeScript being a huge mistake. And I think a lot of other concern is as soon as you start bringing structure in, you're having like flashbacks to Java and all this rigidity. And TypeScript is definitely, as a type language, going to give some rigidity to your life. But if you're working on a project that you want to be maintainable with more than yourself, that rigidity is probably going to pay off really quickly. As soon as, I don't know, I write some code that takes arbitrary things and Estyn has to use it, and he just hits me, then it pays off.
Yeah, for sure. Like where I see this is it's whatever rigidity that you choose to apply. So TypeScript doesn't say you have any rigidity. TypeScript says I give you the ability to add that rigidity. So you get to make that decision. If you go crazy and make it super rigid, then you may actually regret that. But you guys get to make that decision. It gives you the tool to make that option available to you.
Yeah, and one important thing here is TypeScript. Types are an important aspect of what TypeScript is, but its goal is developer productivity, and types are a stepping stone on the way there. All the tools Estyn is showing you off are another tool on the way there. So you can take or leave these features as they make you more productive as a developer and a team. Cool, that's basically our talk here. So does anyone have any questions?
On the previous slide, do we lose flexibilities and deliberate pun? Because TypeScript is excellent pun.
I'm going to say yes. But the real reason is that I can't spell.
On the question of locking in, how ugly is the compiled JavaScript? If we're trying to head to turn all your TypeScript code into JavaScript, could you do that? Could you do it choosing ES5 or ES6 syntax?
So you can. So when you compile your code, you could choose ES5, ES6, ES next, they call it at this point. It could be whatever you want. We have had one client where we did a big refactoring project, but they had no interest in TypeScript. So we wrote the whole thing TypeScript, compiled to ES6, delivered it, and now they have ES6, and it brings across all your comments. It's almost identical. Like it is very, very little. The only things that you really notice is when they bring in shims. The shims are normally brought in, like you can export those into a separate file. so that if you're bringing in, like, if you're trying to do async await in ES5, it's going to bring some shimming. But
I actually just read an interesting blog post from the TypeScript crew about async await and how it compiles down to ES7, 6, 5, and then even down to 3. And like the higher level JavaScripts, it was basically 1-to-1, and then 3 was just an exciting little rat's nest.
Maybe I'll just ask this quickly. If people wanted to get started with TypeScript, what would be the best way to do that? Is it just to download code, or?
I would say just take your JS, rename it to TS, and you're off to the races, right? So immediately you start getting some of the benefits, start slowly typing some things, or start slowly using some of the ES7, ES6 features, depending on what road you want to go down.
Oh, one thing I didn't mention is there's a library called TS Node that you probably saw me use. It effectively is Node, but with a TS on the front, and it just runs TypeScript files, so you don't have to like have a manual compile step if you just want to play around with it as well.
I noticed that I think you defined a function that had a return type on it.
Yes.
What happens if you try to return from inside of a function that doesn't have a return type specified, or does it just let you do that?
You'll infer it. So TypeScript will infer the return type by the fact that you're returning something.
Like it's not like an error.
Nope.
Oh,
However, if you do have a return type specified and you break that, then it's an error.
okay.
And then part if you start with TypeScript and you don't know how to do the enumeration of the interfaces, you just type any.
Yeah.
So
Yes.
you end up JavaScript anyway.
Yeah. Well, you can have no implicit any too, or turn that off, and then it's just regular, right? Like you can have basically JavaScript be TypeScript.
And then
Yeah.
just wait until it's compiled.
Yeah. You can also do like, there's way more advanced language features. You can actually do like null prevention as well if you want to get further down there, which is a bit hairy. If that, then you lose your JavaScript backward compatibility. Well, valid JavaScript then isn't valid TypeScript. But if you get to TypeScript and get far enough down here, it can actually make some really nicely structured code. Swift has basically the same sort of thing where you have optionals, but everything by default can't be null.
So basically what you're saying is the simplest version of TypeScript, it's just a linter. You just write your JavaScript and you have a compile time that is a linter.
Exactly. At the very basics, that's what it is. It's a strict superset. So all JavaScript is valid TypeScript.
But then you can add in these extra little hints to the linter that says this is supposed to be.
Exactly. Yeah.
Exactly.
Well, you don't have the way how to set a function or how the design properties in TypeScript. Like let's say you have an op to open up your brackets and then you have to have like a one tab or one space in between. That's not what TypeScript does.
Okay, yeah.
Yeah. Right.
Basic
Yeah.
stylistic stuff.
Yeah, it's not going to enforce your
There are
style.
styles in TypeScript.
Yeah, it's not going to enforce your style. It's going to enforce your structure,
Yeah.
like
Yeah.
your logic. Yeah.
So is that like where I heard that a lot of the time the compiler will try to still output JavaScript and warn instead of error? Is that kind of part of that then, where it would try to still generate the JavaScript even if it's something that maybe doesn't look right in TypeScript and just assume you know what you're doing?
I'm not sure I've ever run into a scenario where that would be like if you do something
Yeah.
crazy, it will let you do that. So it will output that straight to JavaScript as long as you're not breaking the type system. Yeah.
Yeah.
So yeah,
So
it
it's
lets
still
you.
do
It's
the
like a
JavaScript.
server. It's your own foot. If you decide to shoot it, it's going to let you. So it doesn't stop any of that kind of stuff.
Right, but it would still warn you though.
Yeah, it'll give you a warning that it's not idiomatic JavaScript.
Right.
If you're doing something, I bet if you put that void statement in on a weird spot, you get some weird stuff coming through. But it would let you as long as it was valid.
Okay.
Any more questions?
I've been writing a lot of CoffeeScript lately, and so I feel like I'm gonna miss all those, or I'm gonna not like all the new curly braces. So is there like a support group or something to teach me how to read all those curly
I can
braces
help you
again?
through that. I went through the same thing, and I like white space sensitivity language, but I also like my language to make sense,
Yeah,
which was
Is
a
that-
reasonable trade-off.
yeah.
Yeah.
I still don't understand why people still use coffee.
They made the mistake of starting using it 3 years ago, and now they have to.
Can I just say I like your prompts too?
Oh,
The,
thank
like,
you.
Colors.
You should use ZSH, but that's not what this talk's about.
Okay, thank you.